got another problem up here, same directions. I'm just keeping those up for a while here. This problem looks a little bit different. It's still a linear function in cosine because the power of cosine is still cosine to the first. What's changed is that angle, it's 2x. Now a lot of times when people see that, they say, oh, we'd better use the double angle formula. Let's not, okay? There will be times when we might need to use double or half angle formulas in solving our trig equations. But the only time you're going to need to do that is when you have more than one angle in the problem. Because I can basically solve things if I can have this trig function of an angle is this number. If I can get it in that form, I can figure out what that angle is. Okay? So I don't need to use the double angle formula, and that would actually make things a lot more complicated if I did. Because if I said cosine of 2x is cosine squared minus sine squared, now I've got two trig functions and they're both squared. Now I could use one of the versions like that involves just one other trig function. So I could say it's 1 minus 2 sine squared or 2 cosine squared minus 1, but still I'm bumping the degree up to 2. There's no need to do that. What I need to do is say, I know how to figure out what that angle is. I'm used to that angle just being x, but I know how to figure out what the angle is. So what I'm going to do is I'm going to first of all find 2x in the interval from 0 to 2 pi in one period of cosine. And then I'm going to find all values of 2x. So I'm going to follow my basic procedure, but what I'm finding is the angle, which is 2x. Generally speaking, though, when you're asked to solve an equation, you're not asked to find what twice the variable is. You're asked to find what the variable is. So once I know what 2x is, would I be able to figure out what x is? Yes. I would simply divide it by 2. So once I know all values of 2x, I'm going to find all values of x by simply dividing those by 2. So that's going to be part B. That's actually going to be my third step. Because first of all, I'm going to work with the angle that appears in the equation. And then, once I know all values of x, I'll find x in the interval from 0 to 2 pi. Notice there's a big difference between 2x being in this interval and x being in this interval. I can expect, since 2x is twice as big as x, I can expect there to be more values of x and fewer values of 2x that would fall in that interval. Okay. So let's take a look. As always, I want to isolate the trig function. So I'm first of all going to just subtract over this 3. So I'll have 3 cosine of 2x is equal to negative 2. Can divide both sides by that 3. So cosine of 2x is negative 2/3. Now I look at that and I say that's not going to show up in a 30, 60, 90 or a 45, 45, 90 triangle. Or if I've memorized the unit circle, I don't have any points where x or y is a negative 2/3. Okay. So I'm going to have to describe that using inverse trig. But what quadrants are we in? So since that's negative, we're going to have a value of 2x in quadrant 2. I'm just going to be very careful and label that 2x so I don't think I found x when I'm done. And we'll have a value of 2x that's in quadrant 3. Both of those will have the same reference angle, alpha. And what I know about alpha is that cosine of alpha will be the absolute value of negative 2/3, which is just 2/3. And of course, since alpha is an acute angle, as soon as I know that it's an acute angle and its cosine is that, it is arc cosine of 2/3. So alpha is arc cosine of 2/3. Here, what we had was that 2x was pi minus alpha. Oops. And here, 2x was pi plus alpha. Okay, so let me write those down over here. I'm just going to replace alpha with arc cosine of 2/3. Okay. I'm going to erase this picture so that I've got a little bit more room. But 2x could either be pi minus arc cosine of 2/3 or pi plus arc cosine of 2/3. So those are the two answers for what 2x could be. in this interval. To get all possible values of 2x, I'm going to add a multiple of the period. So I'm going to add a multiple of 2 pi. So this would be pi minus arc cosine of 2/3 plus 2 pi n, pi plus arc cosine of 2/3 plus 2 pi n, where n is an integer. Okay. And again, if I wanted to consolidate and say that's 2n plus 1 copies of pi, I could do that in either of those answers. Okay, so now I want to figure out what x is. Well, all I'm going to do is say if 2x was pi minus arc cosine of 2/3 plus 2 pi n, to figure out what x is, I'm just going to divide through by 2. I just need to be careful. Every single term on the right gets divided by 2. So x would be pi over 2 minus arc cosine of 2/3 over 2. That does not count as a complex fraction because that's arc cosine of 2/3 is one number that's on the top. Okay, it's the angle in the interval from 0 to pi whose cosine is 2/3. Okay, and I'm taking half of that. That half does not change the 2/3. It takes that angle and cuts it in half. And then here in this last term, those 2's cancel, so I get pi times n. Sometimes people try to make the mistake of they take these two things and they cut them in half, and then they add a multiple of 2 pi. But you want to add the multiple of 2 pi before you cut things in half, because all of these are values that 2 pi could be, so half of those is going to be the values, I'm sorry, all of these are things that 2x could be, half of that is going to give me the things that x could be. Okay, so I could have pi over 2 minus arc cosine of 2/3 over 2 plus pi times n, or I could take this and divide it by 2. Again, that's dividing each term by 2. So that would give me pi over 2 plus arc cosine of 2/3 over 2 plus 2 pi n divided by 2 is plus pi n. And I do need to state again that n is an integer. Okay. So now let's take a look and see what are the values that x could be in the interval from 0 to 2 pi. Okay. So what I'm going to do is actually just create here a little table so that we can sort of see what's going on. I'm going to record what n is, and then I'm going to record what I get when I plug into this. Pi over 2 minus arc cosine of 2/3 over 2 plus pi n. Now, if n is 0, that kills off this term, and I've just got pi over 2 minus arc cosine of 2/3 over 2. This is an acute angle, because it's half of arc cosine of 2/3, which was an acute angle. Pi over 2 minus an acute angle is just going to be an acute angle. So it's definitely in this interval. I don't want to let n be any smaller than that. If n was -1, I'd have pi over 2 minus an acute angle minus pi. That would give me a negative angle. That would be too small to be in this interval. But let's see what happens if n is 1. If n is 1, I'd be adding pi to this thing. Pi is the same as 2 pi over 2, so plus pi over 2. It would be 3 pi over 2 minus arc cosine of 2/3 all over 2. Okay. Is that in this interval? Yeah, because that's an acute angle subtracted from 3 pi over 2. That's just going to swing me back into quadrant 3. Okay. Now, if n was 2, I'm going to get something that's too big. because we said this was an acute angle. If I add 2 pi to that, I've gone a full revolution plus that acute angle. Okay, so I get these two answers from this sort of thing. Okay, and I can basically do the same thing here as well. Okay. Now, it's not absolutely necessary that you create a table like this, but you may find it helpful. If you do, if it's a useful tool, use it. If not, no need to write it down. Okay. So here's pi over 2 plus arc cosine of 2/3 over 2 plus pi n. Again, if n is 0, I just get pi over 2 plus arc cosine of 2/3 over 2. That's going to actually be pi over 2 plus an acute angle, so that's an angle in quadrant 2. Okay. Couldn't let n be any smaller, though, because if n was a negative, I'd have this acute angle plus pi over 2 minus pi would be minus pi over 2. I'd have a negative angle. Don't want that. If n is 1, that's pi plus pi over 2 is 3 pi over 2 plus arc cosine of 2/3 over 2 is just an acute angle. 3 pi over 2 plus an acute angle, we're still smaller than 2 pi. But if n is 2, we're too big. So my solutions for x in the interval from 0 to 2 pi are these 4 numbers that I'm boxing in red here. And I'm just going to say these are all the x values in the interval from 0 to 2 pi. So notice with 2x, we just had 2 solutions. With x, we had twice as many. Now, if I think about it graphically, that makes a lot of sense. Because if I graph cosine, cosine does its thing once in the interval from 0 to 2 pi. So this would just be y equals cosine of x. And we were looking for where we got negative 2/3, I think, which was right about here. We're going to intersect at that height at these 2 places. But if I graph y equals cosine of 2x, that cuts the period in half. That's going to do its thing twice over the interval from 0 to 2 pi. So if we're looking for where are we down at a height of negative 2/3, here, 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 and here, we get twice as many solutions. That's kind of a neat trick. If you're working with 2x, you're cutting the period in half because you're going twice as fast through everything. You're going to have twice as many solutions in this interval as what you would have if you were just working with x. All right, I'm going to have you folks try one. Now, we're getting into problems that are a little bit more time consuming, and so in the interests of keeping you motivated to do these things, hopefully you're motivated because it's just so much fun, but to help you out, this is an odd-numbered problem from the homework, so that doing this problem as you work through the videos, you're getting a head start on the homework. So question 27 is root 2 sine of x over 2 minus 1 equals 0. Same directions that we've had before. You're going to find all solutions in the interval from 0 to 2 pi, and you're going to find all solutions. Of course, those solutions are going to be x. So what I recommend is that you follow a strategy similar to what we did here. You're going to first find x over 2 in one period of sine, then find all x over 2, then find all x, and then find x in the interval from 0 to 2 pi. Okay, so go ahead and do that. We'll go over that one together in the next video.